have a paragraph question here. This is the paragraph given to you, and two questions are asked here. Okay, so function f is given to you, function g is given to you, and they are looking for these integrals. Now if we are smart enough, what do we see that this particular integral is occurring in both of them. Okay, so what we have to do is we will just go ahead and try to evaluate, then maybe I will, whatever I get, I will use in both of them. Okay, so let's get started. So 0 to pi by 2, what is my f of x? Sine square x. What is my g of x? This function. Okay, let's write that. Under root pi by 2. Can I take x common, you see? Yeah, you see that I can take x common here like this. As soon as you take x common, something looks very evident, right? You have x and you have pi by 2 minus x. So which property do you want to use? Remember this property? We are going to use that. Okay, let's do that. So 0 to pi by 2. Instead of x, you are going to write pi by 2 minus x, right? A plus b, in my case, it's pi by 2. Okay, sine square pi by 2 minus x. Pi by 2 minus pi by 2 minus x, and here also pi by 2 minus x dx. Okay, so what happens to this particular thing? Sine pi by 2 minus x is cos x. So you end up in getting cos square x, and here you end up in getting pi by 2 gets cancelled, x times pi by 2 minus x dx. Now, do you see what is happening here? This is your I. This is also your I. But what did you see? That sine square x changed into cos square x. Okay, so what do you think we should do now? Yeah, adding the two. Okay, so let's do 2i. Okay, adding two of them together. So what happens? The integral limit, of course, is going to remain the same. The only thing is going to happen is sine square x and cos square x will give you a 1, and inside the under root you are going to have pi by 2 minus x times x, because these two things are same in both of them, right? Okay, dx. Now, did you realize what happened? F of x is gone. You are only left with g of x. Okay, because what you have got is, this is pi by 0 to pi by 2 g of x dx. So you got 2i is this. Now look at the first one, what they're asking. They're asking 2i minus this. Okay, what do you think it should be? Now 2i minus integral 0 to pi by 2 g of x dx would be what then? 0, because they're equal, right? So you got this answer. But still I'm not done, because they're actually looking that, can no, you have to give me this value. Okay, so let's get going then. So this was I, right? Later on we will multiply by 16 upon pi cube. So my I is, or let me just write 2i, it is pi by 2x minus x squared. You remember how do we do these kinds of integrals? Completing the square. Let's do complete the square. Okay, you have minus x squared minus pi by 2x. What should I add to complete a square? B by 2a whole square. That's what we add to add them up. Okay, all good. So now what? You're done. Okay, basically you end up in getting in the format a square minus x square. So let's write what is my a square. It's pi by 4 whole square. That's a square. And what is my x square? X minus pi by 4 whole square dx. You know what to do from here. Okay, but let's complete it up. I will do a substitution. I will plug in x minus pi by 4 as a t. Okay, so what happens to this if I do that? Limit changes, because when x is 0, my t is pi by 4. When x is pi by 2, then pi by 2 minus pi by 4, that's pi by 4. That's the limit for t. And inside the under root, you have pi by 4 whole square minus t square dt. Little more simplification, because this is an even function of t. So minus a to a becomes 2 times 0 to a. So let's write that. So my 2i is 2 times 0 to pi by 4 under root a square minus t square dt. Okay, so 2 you get cancelled here. Now you use your formula. Okay, do you remember the formula? X by 2 under root a square minus x square plus a square by 2 sine inverse x by a. That's your formula. Okay, now you just put the limits. Last thing we have to do. So what happens when you put the upper limit? On upper limit, this goes to 0. Okay, only this remains. Let's write what is this? Pi by, okay, so this happens to be pi square This is 16 and 2, 32. Okay, and then you have sine inverse pi by 4 by pi by 4, that is sine inverse of 1. Lower limit, this t goes to 0, this whole thing is 0. This is 0, sine inverse 0 is again 0, so only this much. So pi squared by 32 and sine inverse of 1 is pi by 2. So you get pi cubed by 64. What are they looking for? They're looking for 16 upon pi cube times I. That's 16 over pi cube, and I value I got to be pi cube over 64. So very easy, very nice answer. 1 by 4 is my answer, or 0.25 is my answer. So we just fill in here that it's 0.25. Okay, nice question. See you with another one.